Hello, my name is Jake, and our team was assigned the incredibly interesting career path of aerospace engineering. There has been a renewed interest in aerospace engineering recently due to innovative people like Elon Musk and Jeff Bezos that have revived the idea of interplanetary travel and space exploration. This has led to many companies involved in aerospace engineering receiving more funding and projects. Aerospace engineering is a diverse field with many opportunities to specialize in. They research, create, and repair a variety of vehicles that operate both within the atmosphere and in space that require very unique designs, structures, and materials. This is aeronautical engineering and astronautical engineering, respectively, which also happen to be the two main subdisciplines. Some of these vehicles include airplanes, satellites, and rockets for both military and civilian uses. Aerospace engineering falls under the major of mechanical engineering. Mechanical engineering is the field of engineering that specializes in the research and creation of anything that's mechanical. This includes the research and creation of trains, cars, airplanes, speakers, and engines. Today, our team is going to discuss the discipline of aerospace engineering, such as education, daily life, and projects that aerospace engineers get to work on.
Aerospace engineering has many different career path potentials, but before one would have the opportunity to be employed as a rocket scientist, there's a somewhat rigorous educational program that needs to be completed. Luckily for us civilians that enjoy traveling by plane rather than vehicle or ship, becoming an aerospace engineer is not an easy process. Most employers looking for the next aerospace engineers are looking for someone with a master's in aerospace engineering. Some may accept a bachelor's, however, most are inclined to hire those with a master's degree. Fortunately, colleges often offer a 5-year Master's of Science program for aerospace engineering. There are many colleges that offer aerospace engineering. Some of these include Stanford University, Massachusetts Institute of Technology, University of Michigan, Ann Arbor, Arizona State University, and the University of Arizona. Stanford and MIT have about a 4% acceptance rate, while University of Michigan has a prestigious and historical aerospace program with a 20% acceptance rate. It is the oldest aerospace program in the U.S. with superior research centers which specialize in both aircraft and spacecraft. This provides learning experience that constantly pushes the boundaries of the curriculum, allowing students to have a hands-on approach. University of Michigan alumni are highly recruited by government agencies and private corporations, including NASA, Boeing, SpaceX, Airbus, and many others. If someone is in pursuit of an aerospace engineering career, they should be looking for opportunities to gain experience in the form of internships and REUs or research experience for undergraduates while pursuing their degree, as employers often look for not only the degree but experienced engineers. One may apply for internships at any company that is involved in aerospace, but some of the most popular internships include names most are familiar with, such as Kratos Defense, Georgia Tech Research Institute, Lockheed Martin Corporation, and Honeywell. Many universities have REU programs, and our interviewee acknowledged how important it is to become a part of a REU, and also stated that his company, L3 Harris, offers programs to new engineers and engineering students to work with people at L3 Harris to develop parts for aircraft as well as other projects. The educational pathway is an extensive program which is understandable with the time, resources, and lives it affects on a daily basis, but it is a largely rewarding endeavor.
A way for an engineer to get connected in a certain discipline is to join an engineering society. These societies provide an opportunity for engineers to share best practices and network with each other. Some of these societies for aerospace engineering include the American Institute of Aeronautics and Astronautics, which provides a calendar of events related to the aerospace field, research, technical information, publications, and educational services. Also, we have the American Helicopter Society International, the Vertical Flight Society, which emphasizes and progresses engineering advancements in traditional rotorcraft disciplines and working towards implementing this focus to the multidisciplinary fields of vertical flight. We also have the Aerospace Industries Association, an association that represents the industry's leading manufacturers and suppliers of civil business and military aircraft, helicopters, missiles, spacecraft, and all materials and related items. Also, we have the Aerospace and Electronic Systems Society, which are involved with the organization, designing, and developing of systems such as navigations, avionics, radar, sonar, and telemetry, to name a few. Applications are for complex systems for space, air, ocean, or ground environments. Lastly, we have the Aeronautics and Space Engineering Board, which provided an independent forum for everything space engineer and aeronautics research that falls within the National Research Council. According to our interviewee, it is very important for an engineer to get connected with other engineers because it creates a lot of great employment opportunities, and it seems like societies are the easiest place to get connected.
There are many jobs available for aerospace engineers. The most famous companies aerospace engineers want to work at are Lockheed Martin, Northrop Grumman, and Honeywell. These companies are difficult to get interviews for and is even more difficult to get a job offer. Some ways to get opportunities to work at these companies is to make connections with people that's already working in the company. This makes it easier for an engineer's resume to make it to the hiring department's desk. If an engineer does not have these connections, another thing they can do is thoroughly research the company. That way, when the engineer gets interviewed, the interviewer is impressed by the effort that they went through to get an interview, showing that the engineer really wants the opportunity to work at the company. There is an immense amount of technical and soft skills required for an aerospace engineer to succeed in a career. The most important soft skills of any engineer is great teamwork. If an engineer cannot work in a team, they will really struggle to make any progress in a career. According to our interviewee that works at L3 Harris, says that a skill that was really not discussed at school was requirements management. Requirements management is where a client will specify the requirements for a project, such as the amount of vibration it needs to withstand, the strength of the material, and the amount of heat or cold it can withstand. There are sometimes thousands of requirements for a project, and each requirement needs to be tested, leading to thousands of tests. Some technical skills include vibration, computer-aided design, aerodynamics, propulsion, structural analysis, which is crucial for producing aircrafts that can withstand the forces and stress endured during flight, and flight systems, which has to do with the knowledge of control theory and avionics systems that ensure stable and controlled flights, and also NAG. A engineer's work life can be stressful when there's a lot of projects that need to be finished soon, but it is extremely fulfilling to create something that works and flies.
There is a vast number of projects that an aerospace engineer works on, such as commercial aircraft, rockets, hypersonic aircraft, and satellites. There is a large number of considerations that go into each type of vehicle, such as hypersonic aircraft. An aerospace engineer needs to have the knowledge of material science, thermal management, and aerodynamics. The extreme speed that these aircraft reach cause great stress on the metals and other materials used to make these aircraft. An aerospace engineer needs to make the right decision on what materials to use in their aircraft in order for it to reach supersonic speeds. Then, an aerospace engineer needs to design ways to decrease and manage the heat caused by the jet engine and exhaust. This is an extremely important procedure because if the temperature is not controlled, it could cause overheating, leading to damage to the structure, and it could potentially risk the pilot's life. Aerodynamics is crucial for creating aircraft, especially when the aircraft is going supersonic speeds. An aerospace engineer needs to decrease the drag as much as possible to reach higher speeds and reduce stress on the structure. Now, if an aerospace engineer wants to make a rocket or satellite that goes into space, there are thousands of other things they need to take into consideration. According to our interviewee, one such consideration is that radiation in space causes electrical malfunction. This could range from just a little glitch that turns off systems, or it could cause the whole system to short out. This means that aerospace engineers need to research and design ways to protect electrical systems from radiation in space. There are a great number of projects an aerospace engineer works on. This is merely the tip of the iceberg, but it gives someone who is interested in aerospace engineering an idea of what they can do in this discipline.
Today, we talked about aerospace engineering, the education needed, the work life, and the projects that they work on. Aerospace engineering is a notoriously difficult major to learn, but it is highly interesting and it gives a sense of accomplishment when a person graduates with this degree going on to a job to build great things. The work life of an aerospace engineering is busy as of late because of the renowned interest in aerospace engineering. Aerospace engineers work long hours to design and build parts. These parts take a lot of skills in mathematics, physics, materials, and aerodynamics. These parts that engineers work on to create something that seems beyond common sense is almost like they've developed into the realm of magic. Without aerospace engineering, we would not be able to travel the globe or look at the vast reaches of the universe. Thank you.